Signal Acquisition Cuervo. Before the Cassini mission to Saturn, the moon Enceladus could easily have been thought of like countless other objects in our solar system. A cold, small, and outer moon likely void of life. Lack of sunlight at Enceladus is due to the faint sunlight that reaches Enceladus at 10 times the distance that the Sun is from the Earth. The moon's small size, with just over a 500-kilometer diameter, also aids in its frigid temperature. Able to fit comfortably within the North Sea, its larger surface area per unit volume compared to other worlds keeps it unable to accumulate heat. Most early estimates were that it was frozen solid. Before Cassini, the moon was known to be one of the widest and brightest objects in the solar system. This led to the hypothesis that it must have been frozen ice, which is the only known thing to reflect near 100% of sunlight. It would also lead to the idea that the moon was rather young. Combined with being in Saturn's E-ring, the next question was whether the ring formed Enceladus, or if somehow Enceladus was creating the ring. On approach to Enceladus, and at a distance, Cassini's magnetometer showed magnetic field lines bending near its south pole, almost as if an atmosphere was present. Its cosmic dust analyzer also detected thousands of dust-sized particles. The intriguing first returns were bolstered by images showing linear features with a varying color to the rest of the uniform white surface. With the result from early instrument readings, on Cassini's third pass of the moon, a much closer approach at 175 kilometers in altitude was set, with multiple pixel resolution cameras ready. Cassini scientists found what appeared to be a surprisingly dense cloud of water vapor and ice grains over the South Pole, confirming earlier suspicions that Enceladus is the main source of material for Saturn's E-ring. Temperatures for the moon were expected to be colder at the poles, where less sunlight would reach. However, Cassini confirmed a slightly warmer South Pole and much warmer areas where the linear formations were seen. Thinking that it resembled water evaporating at the fissures much like a comet, the idea soon lost favor when concentrations of various other materials were also seen in the plumes. The heating that was causing the vapor was theorized to be tidal in nature or radioactive, but not sunlight as in comets. In March 2008, Cassini finally confirmed the material in the plumes. Water and other materials were shooting out of the moon at 1.3 kilometers per hour, or 800 miles an hour. Ion spectrometry of the plume showed water vapor, carbon dioxide, carbon monoxide, and other organics all at high densities. New heat maps even showed the shape of the lines as V-trenches. Finding salt grains in the E-ring in 2009, it was not until 2011 that the plume from Enceladus was shown to create not only a ring, but a torus as it continued to expel material. Later on, this was even confirmed by the Webb telescope. In 2014, using data from Doppler shifts observed on the surface of Enceladus, scientists announced the likelihood that Enceladus hosted an ocean under its surface, some 10 kilometers deep and 30 or 40 kilometers under the surface. In early 2015, evidence indicated that Enceladus might have hydrothermal activity, which would make it the only place beyond Earth where such conditions have been shown to exist. With data showing a wobble in the moon's orbit, researchers created models of how Enceladus could be put together on the inside. The only model that fit was if a liquid layer completely separated the porous rocky core from the icy shell. The moon simply couldn't wobble so much if the shell and the core were solidly connected. Enceladus surely had a global ocean under its icy shelf. Scientists believe that the seawater flows deep into the seafloor, where it gets heated and reacts with minerals in the rocky crust emanating from geothermal vents. Rising from the seafloor, it carries dissolved minerals up with it and just might allow for a rich ecosystem along the way to the fissures. Over the course of the mission, instruments detected in Enceladus plume organic and nitrogen-bearing molecules, such as acetylene, ammonia, carbon dioxide, and methane. Most recently, on June 14th, phosphates were added to the list of molecules detected. A new article, written by a team that analyzed data from Cassini, looked at the specific findings of the cosmic dust analyzer. The results of the team closely parallel recent modeling of mineral solubilities in Enceladus' oceans. The link to the full article is in the description. The paper shows the mass spectra of ice grains in the plume of Enceladus, showing the presence of sodium phosphates. The results, backed by lab analog experiments conducted by the team, suggest that phosphorus is most likely abundant in the ocean of Enceladus in the form of orthophosphates. The concentrations of phosphorus might even be 100 times higher than in the ocean waters here on Earth. The team summed up their findings in their discussion section while comparing results to what is found on Earth, and conclude with the following. Quote, regardless of these theoretical considerations, with the finding of phosphates, the ocean of Enceladus is now known to satisfy what is generally considered to be the strictest requirement of habitability. With this new report on findings from Cassini, we can review all of the confirmed factors for possible life on Enceladus. Ocean temperatures and pressures in the range with those observed on Earth, a pH that is somewhat basic between 8 and 11, comparable to an early Earth, salinity that falls into a habitable range for organisms that we know on Earth, and finally observations of complex molecules that could support methanogenic life with abundance of carbon, hydrogen, nitrogen, oxygen, and now phosphorus. Chances of finding life here is unknown, but the chemistry it would need to flourish is already there. Thanks for watching. If you enjoyed content like this, please consider subscribing, liking, sharing, and commenting on this and other future videos. Also, remember to follow us on Twitter and Instagram for more space content.